Partial angles, angle 45 degree. Consider a right angle isosceles triangle of side 1 unit. This is an isosceles triangle and this part of it is 1 unit. This part of it is also 1 unit. From this isosceles triangle, we will be able to derive standard angles for sine 45, cos 45, and tan 45. Now, in an isosceles triangle, two of the angles are equal, which are this angle and this angle. Let's assume that the angles is alpha. Being a right angle triangle, it implies that the angle here is 90 degree. So this is 90 degree, while this angle is equals to this angle. Then this is 1 unit, this is 1 unit. Let's assume that the hypotenuse is x. So at this point, we're going to find the value for x. I'll also find the value for alpha. Let's find x first. We can find x from Pythagoras theorem. Let's assume that this is A, this is B, and this is C. Pythagoras theorem states that the square of the longest side A is equals to the square of B plus the square of C. That is A square is equals to B square plus C square. Applying this theorem into what we have here, we have that A, which is x square, is equals to B, which is 1 square, plus C, which is also 1 square. So x square is equals to 1 plus 1. X square is equals to 2, and x is equals to the square root of 2. So hence, the value of the longest side of the triangle is the square root of 2. Let's find the angle, alpha. This angle here is 90 degree. That is what is symbolized by this sign. And this is alpha, this is alpha. The sum of the angles in a triangle is 180, which implies that 90 plus alpha is equal to 180 degree. So we have that 90 degree plus alpha is equals to 180 degree. Find the value for alpha. We have that 90 degree plus 2 alpha is equals to 180 degree. If we take like terms, 2 alpha is equals to 180 degree minus 90 degree. 90 will cross over to the other side of the equation. This implies that 2 alpha is equals to 180 minus 90, that is 90 degree. And when we divide both sides by 2, alpha will be equals to 45 degree. So we will be able to derive the value for alpha. So right now we know the 3 angles and we know the value for the 3 sides. Let's just draw the triangle again with the updated information. This is the triangle. This angle here is 90. We know the value of these 2 angles now. This one is 45 degree. This is 45 degree. This distance here is the square root of 2, where this is 1 and this is 1. Now remember the acronyms used in trigonometry ratio. It is SO, CA, TOA. At this point, we need just one angle. We need just one angle to find the value for sine, cosine, and tan. So let's make use of this angle here. So the other one, we can eliminate it for now. So let's identify the 3 sides of this triangle. The longest side is the hypotenuse. The side that is opposite to this angle is called the opposite. While the last part of the triangle is the adjacent. For sine, we'll make use of this first one here. This represents sine, which is sine theta. is equals to O. O represents opposite, all over H. H represents hypotenuse. Applying this formula in the triangle, we have that sine 45 degree, which is theta, is equals to opposite. Opposite is 1 over hypotenuse. Hypotenuse is the square root of 2. Hence, sine 45 degree is equals to 1 over the square root of 2. So let's proceed to the cosine. Cos theta is equals to A adjacent over H hypotenuse. Hence, cos 45 degree is equals to adjacent. Adjacent is 1 over hypotenuse. Hypotenuse is the square root of 2. Cos 45 is also equals to 1 over the square root of 2. So what about tangent of 45 degree? Now let's work with tan, which is t here. Tan theta is equals to O. O is opposite over A adjacent. Applying it into the triangle above, we have that tan 45 degree is equals to opposite. Opposite is 1 over adjacent. Adjacent is 1. Hence, tan 45 degree is equals to 1. So we have been able to find a standard angle for sine 45 degree, cos 45 degree, and tan 45 degree. These are special angles of 45 degree. Let's move over to angle 60 and angle 30. Consider an equilateral triangle of side 2 units. So we have an equilateral triangle. An equilateral triangle implies that the three sides are equal. The unit of each side is 2. So here is 2, here is 2, and here is 2. If the three sides are equal, it also implies that the three angles inside are also equal. So if here is A, here will be A, and here will be A. And remember that the sum of the angles of a triangle is equals to 180. And this implies that A plus A plus A is equals to 180. 3A is equals to 180. And so, if we divide both sides by 3, A is equals to 60 degree. Hence, these three angles, they have 60 degree. Hence, this angle here is 60 degree, this one is 60 degree, and this is 60 degree. The unit remains 2. So what happens if we decide to bisect this triangle? Let's bisect it. So let's cut it in 2 from here. So if it's perfectly equal, this angle will be 30 degree, and here will be 30 degree. 30 plus 30 will give us a 60 degree angle here. Now this is what we're going to do. We're going to take one part of the bisected triangles. We have 2 triangles here. Let's take one part of it. I'm going to take the one at the right. This angle is 30 degree. This one here is 60 degree. Yes, 2. Now let's take note that since the triangle is bisected, from here to here is 2. Now if we cut 2 in half, it means that from here to here will be 1, and from here to here will also be 1. So here's 1. We will need to find the distance from here to here, and we can do it with Pythagoras theorem. Let's assume it is y. Remember that Pythagoras theorem states that if the longest part is a and here is b, here is c, then a squared is equals to b squared plus c squared. So if we apply this, we have that 2, which is the longest part, square is equals to y square plus 1 square. And this implies that 4 is equals to y square plus 1. If we take like terms, 4 minus 1 is equals to y square. Hence, 3 is equals to y square, and y is equals to the square root of 3. So, the distance here is the square root of 3. That's what we're going to do. We're going to split the angle. We'll work with angle 60 first, and then we'll work with angle 30 later. So for angle 60, we have this triangle. Angle 60, the distance from here is 1, this distance is 2, and this is square root of 3. So with this, we'll be able to find a standard angle for sine 60, cos 60, and tan 60. And we're going to make use of SOH, CAH, TOA. For sine, which is x, sine theta is equals to O, opposite, over h, hypotenuse. Hypotenuse is the longest side. The side that is opposite the angle is the opposite, and the last part is the adjacent. Applying this, we have that sine 60 degree is equals to opposite, which is root 3, over hypotenuse, which is 2. Also, cos theta, represented by C, is equals to A, adjacent, over H, hypotenuse. Hence, cos 60 degree is equals to adjacent, which is 1, over hypotenuse, which is 2. Cos 60 degree is equals to 1 over 2. And then let's move to tan. Tan theta is equals to O, opposite, over A, adjacent. Tan 60 degree is equals to opposite. Opposite is the square root of 3 over adjacent. Adjacent is 1. Hence, tan 60 degree is equals to root 3. And these are the special angles. Sin 60 degree is root 3 over 2, cos 60 degree is 1 over 2, and tan 60 degree is root 3 over 2. Now let's go back. We are done with 60 degree. We're going to draw the triangle again, and this time around we'll work with 30 degree. So this is the triangle. This is 30 degree. Here is 1, here's 2, and here's the square root of 3. So this is the hypotenuse. This part is opposite because it's opposite to the angle 30, and this is adjacent. Remember the SOH, CAH, TOA. For sine, sine theta is equals to O, opposite, over H, hypotenuse. Sine 30 degree is equals to opposite. Opposite is 1 over hypotenuse. Hypotenuse is 2. Sin 30 is equals to 1 over 2. Let's work with cosine. Cos theta is equals to A. A is adjacent. And H is hypotenuse. So cos 30 degree is equals to adjacent. Adjacent is root 3 over hypotenuse is 2. Tan theta is equals to O, opposite, over A, adjacent. So tan 30 degree is equals to opposite is 1 and adjacent is root 3. And this is the special angles for angle 30 degree. Sin 30 degree is 1 over 2, cos 30 degree is root 3 over 2, tan 30 degree is 1 over root 3. Now let's list out all the special angles that we have derived. Angle 45 degree. Sine 45 degree is equals to 1 over root 2. Cos 45 degree is equals to 1 over root 2. Tan 45 degree is equals to 1. Angle 60 degree. Sine 60 degree is equals to root 3 over 2. Cos 60 degree is equals to 1 over 2. And tan 60 degree is equals to root 3. Angle 30 degree. Sine 30 degree is equals to 1 over 2. Cos 30 degree is equals to root 3 over 2. And tan 30 is equals to 1 over root 3. So these are the spatial angles. We'll move on to solve just one example. In the diagram below, BAC is equals to 30 degree, and the distance between A and B is 10 centimeter. Find Y. So that's the diagram. We have that the longest side is 10 centimeter, which is hypotenuse. The hypotenuse. Then this is the opposite. So this is the hypotenuse. The hypotenuse is always opposite to 90 degree. This is opposite to the angle given. And the last part is the adjacent. In order to find Y, we just make use of these acronyms. So, car, toi. Now, how do we know the one to use? It's easy. It depends on the information given. In the information given, we have hypotenuse 10. We're looking for opposite Y, but we're not interested in A. So we're going to pick out the one that does not have adjacent on it. The one that does not have A, because we're not interested in it. So there's A here and there's adjacent here, we don't need them. We need the one that contains opposite Y, which we are looking for, and hypotenuse 10, which we are given. And that is sine, OH, opposite and hypotenuse. So we're going to make use of sine theta, which is equals to O, opposite, over H, hypotenuse. So sine 30 degree is equals to opposite, opposite is Y, over hypotenuse, hypotenuse is 10. The good thing is we know the value for sine 30 degree now with special angles. Sine 30 degree is 1 over 2. So we're going to substitute 1 over 2 for sine 30 degree, which is equals to Y over 10. At this point, we're going to cross multiply. 1 times 10 is 10, and 2 times Y is 2Y. Divide both sides by 2. 2 cancel 2. 2 here 1, 2 into here is 5. So we have that 5 is equals to Y, and Y is equals to 5 centimeter. With the help of spatial angle, we didn't look out the trigonometric table to get the value for sine 30 degree. For special angle, you were able to find the value of sine 30 degree, which is 1 over 2, substitute it in and solve your problem to get your answer. If you have any problem based on spatial angle, feel free to ask me on WhatsApp. The topic for my next video is ratios of angles from 0 degree to 360 degree and beyond. You can click on the link above this video to access my next video. I will see you in my next video. Meanwhile, subscribe to my channel, like and share this video. Bye.